Cardinal number of a set. Cardinal number of a set means the number of elements in a set. The number of distinct elements in a set is called the cardinal number of the set. Now, for example, the cardinal number of a set A is denoted by n of A. N means number of elements in the set A. So cardinal number of set A is denoted by n of A. Now consider this example. Here we have a set A such that set -1, 2, 3, -2, 4, and here we know that there are 5 elements in the set. 1, 2, 3, 4 and 5 elements. So the cardinality of this set A can be written as n of A is equal to 5. So cardinality means the number of elements in a set, and it is denoted by n of the name of the set. If it is A, then n of A. Now consider second example. We have another set B is equal to days of a week. Here, if you take the first example, A is equal to set -1, 2, 3, -2, 4. Here the elements are listed out. So it is actually the second representation of set second type, that is roster method or tabular form, since the elements are listed out. But in this example here, description about the set is given in curly bracket, so it is called description method. So days of a week, and clearly we know which are the days in a week, and there are 7 days. So cardinality will be written as n of B is equal to, here because B is the name of the set, so n of B is equal to 7 because there are 7 days in a week. Next we have types of sets. First one, finite set. Finite set means if you are able to count the number of elements in a set, then we can say that it is a finite set. For example, set of natural satellites of Jupiter, set of 2-digit prime numbers, set of even numbers less than 10, set of prime numbers less than 20. These are all examples for finite sets because we are able to count the number of elements. Second one, infinite set. Infinite set means if you are not able to count the elements, then we can say that it is an infinite set. If the elements of a set cannot be counted, the set is called an infinite set. Example, set of fractions lying between 1 and 2. We are not able to find out or count the number of fractions between 1 and 2. Same way, we cannot say the integers less than 10, because integers less than 10 are 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, etc. So we are not able to count the set of integers less than 10. So it is an infinite set. Next we have empty set. Empty set means if a set contains no element, then it is called an empty set. And the empty set is denoted by the symbol. You have to just put the curly bracket with no elements in the set because it is an empty set, or 5. And the cardinal number of an empty set is 0, so we can write as n of empty set is equal to 0. Now example, set of prime numbers between 5 and 7. We know that there is no prime number between 5 and 7, so the cardinality will be 0, and hence it will be an empty set. Next we have singleton set. Singleton set means the set which contains only one element is called a singleton set. The set which contains only one element in a set, that is called set which contains only one element in a set is called singleton set. Now for example, B is equal to set 5. Here we have only one element 5 in the set B, so this is a singleton set. Otherwise we can take A is equal to set the number of stars in our solar system. So it is a singleton set because it contains only one element. Universal set. A set which contains all the elements of the sets under consideration is called a universal set. It varies from set to set and is denoted by capital U. And we can have more than one universal set for the same set. Universal set means a set which contains all the elements of the sets under consideration is called a universal set. For example, here if we have a set A is equal to set Earth, Mars, Jupiter. And we know that Earth, Mars and Jupiter, these are planets of the solar system. And since there are many other planets, so we can say that the universal set may be planets of the solar system. Clear? Now another example, B is equal to set 1, 3, 5, 7, 9. And we know that 1, 3, 5, 7, 9 are natural numbers. At the same time they are odd numbers. So we can consider many universal set. First one, we can consider universal set U is equal to set X is that X element of N. N means natural number. Here each of the element is a natural number, so we can consider universal set as a set of natural numbers. Otherwise, since all these are odd numbers, we can consider the universal set as set odd numbers. Okay, this is set builder form and this is description method. Now next we have equal sets. Equal sets, here consider one example. A is equal to set 1, 2, 3, 4 and B is equal to set 4, 1, 3, 2. Here we can see that in both the sets A and B, all the elements are same. So we can say that two sets A and B are said to be equal if they have same elements, and it is written as A equal to B. So A equal to B, you have to understand that the sets A and B have same elements. So now if you write A is equal to B, then we can say that A and B are equal sets. Because here we can see that in this example A and B both the sets have same elements. Here we have 1, 2, 3, 4. Here we have 4, 1, 3, 2. So both have same elements and then they are said to be equal sets. Now next one, equivalent sets. Equivalent sets, consider the example first. We have a set A, colors of the rainbow, and the cardinality is given here. N of A is equal to 7. We know that there are 7 colors in the rainbow and therefore cardinality will be, number of elements will be 7. Then second one, B, another set with the days in a week. We know that there are 7 days in a week, so cardinality will be N of B is equal to 7. Now here we can see that both the sets have same number of elements. Same number of elements. That means cardinality of both the sets are same. Here for the first set A, cardinality is 7, and for the second set B, cardinality is 7. Since they have same number of elements, we can say that A and B are equivalent sets. So A and B are equivalent sets since they have same number of elements. Overlapping sets. Two sets A and B are said to be overlapping if they have at least one element in common. So if two sets A and B have anything common, then we can say that these two sets are overlapping. So two sets are said to be overlapping if they have at least one element in common. Now consider one example. Here we have set A is equal to letters of the word Delhi, B is equal to set letters of the word Bhopal. And here we can see that in the first set, if you list out the elements, we can have the elements as D, E, L, H, I. And for the second set B, the elements will be B, H, O, P, A, L. And we can see that two elements are common. Which are common? L and H are common in these two sets A and B. Hence we can say that A and B are overlapping sets. Disjoint sets. Two sets A and B are said to be disjoint if they have no element in common. For example, set A, set of even numbers, and set B, set of odd numbers. Since these two sets don't have any number in common, we can say that these two sets are disjoint sets. So two sets A and B are said to be disjoint if they have no element in common.